Taking a look at the practice problems, Unit 1, Worksheet 7 if you want to number it, we are given a problem concerning a speeder and a cop. So as I'm listing my information, I want to make sure I have two distinct organizational patterns. So I've got the car over here, the speeder in this case, and the cop on this side, just so we can have those two ideas right next door to one another. So in the problem it states that our car, or our speeder, is traveling at 115 kilometers for every 1 hour. It gives us that our cop has a velocity of 145 kilometers for every 1 hour. It says that our cop also begins at the top of an on-ramp, so we're going to give him the initial position of 0 kilometers. And it says that at that time, the speeder is roughly 175 meters ahead, or 0.175 kilometers ahead. The things we don't know in this case, we don't know what their final position will be. We also don't know how long it'll take the cop to overtake the speeder. That's actually what we're looking for in this problem, so it's okay that we don't know it. But it gives us a bunch of unknowns that we're going to have to deal with. But you notice that there are some striking similarities in the way that we can drive these two ideas together. So at one point in time, we know that the cop is going to have to overtake the speeder. So we know that the final positions in both cases have to be the same. So in this case, we can say that that is true. This is a huge sticking point for helping us solve this problem. Now, remember that this is true. That at some point in time, the cop has to overtake the speeder, and they're going to be at the same position at the end of the problem. We also have a distinct formula for that. We know that x final equals our velocity times a change in time plus an initial position. Given this idea over here, we can take that and we can kind of plug it in over here because we know that both our final positions are the same. So we can expand these two right here into this equation over here. The only thing we have to be really careful of is that we keep in mind that one side is going to be the speeder and the other side is going to be the cop. So I'm going to label those just so we can keep them straight. So the only information that's going to go on the right-hand side is for the cop. The only one that's going to go on the left-hand side is for the car. So recall that the velocity for the car is 115 kilometers an hour. I don't know the time interval, so I'll leave that in there as an unknown. I do know that its initial position, at least as we've defined it, is at 0.175 kilometers. Also recall that the velocity for the cop is 145 kilometers per hour. Again, we do not know the time, so we'll leave that in there as an unknown. And we know that it's starting, he's starting at the top of the ramp or at the 0 kilometer mark. If you take a look at your equation, it looks like we have two unknown quantities because times are on both sides, but one side's for the cop's time, the other side's for the car's time. We have another trick up our sleeve though. We know that the time in both cases has to be the same. We're observing it at the same starting time, and we know that when the cop catches the speeder, they'll be ending at the same time. So delta t is the same in both cases. So we're actually going to end up solving for delta t here. So solving for delta t, I'm going to move some numbers around, do some algebra. So I want to move this over to our right-hand side. So I'll subtract 115 kilometers per hour times delta t from both sides, so those will cancel out over here, and I'm going to subtract 115 kilometers per hour times delta t on this side. And so our new equation looks a lot like this. I've got 0.175 kilometers equals 30 kilometers per hour times delta t. So then we'll divide by 30 on both sides, which will yield us our answer. And you're going to get an answer in hours, which in this case Our answer in hours, we get 0.005 8 hours equals our delta t value, which in this case is the equivalent of 0.35 minutes, or about 21 seconds. So that's how we would solve that problem. You can use similar ideas in terms of number 4 on the worksheet, but the only thing you have to be really careful of is that you consider direction. We have one football player starting at the 0, and we have one person starting at the 100. They're heading towards each other, so one has to be going in the positive direction, one has to be going in the negative direction. Make sure you define your coordinates. Good luck. Any questions, make sure you email me, and I will get back to you as soon as possible.